Let's take another look at tangent lines. There are two types of problems that we're going to take a look at quickly. One is when you're looking for the equation of a tangent line, and the other one. And so here we go. When we are looking for the equation of a tangent line, we are always going to do slope, then find the point, and then the equation. Because to use this slope-intercept form, we're going to need to have a number for the slope and an x and y for the point, and then solve for the b, and then we'll be done. Now you'll notice we've got a couple different numbers here. One when x is 3, when x is 0, and when x is -1. And all three of these work the exact same way, but some of them look a lot easier than the other ones do. When you take this original function and find the derivative is the same regardless of what the x value is. And then you have to go ahead and substitute in to get the slope, because that gives you the instantaneous rate of change at that particular x value. And so when we do that for here, we get a slope of 9. This one, it just collapses because the x is 0. And again, here, interesting, we get a slope of 9. And the next thing is we need a point. But when you're looking for the point, you need the y value that goes with this x value. And so you substitute into the original function, and that gives us our point. For this middle one, again, when we use the 0, this thing collapses to give you 0. And then this last one, when you substitute in, you get a different point. So again, slope, point, and then equation. So you're going to use y equals mx plus b. You're going to put the x and y in the slope, and it'll solve for the b. And do that on every single one. So you end up with this particular process. The different x values don't really make a difference in the process. It's all the same. Some of them give you different looking equations, but others you're good to go. And this is different because this is giving us a derivative that is 0. That's telling us that the slope of the tangent line is 0, so it is going to be a horizontal line. And what's the equation of a horizontal line? Y equals a number. Is when you are looking for the points at which a tangent line has a specific slope. Now when you're looking to find the points at which you have a specific slope, here are 3 different equations, and we want to have a slope of 3. So for each one of these, we are going to take the derivative, set it equal to 3, then we're going to solve for the x. That tells us where that function has that particular slope, and then we find the y values because we're looking for points, not just x values. So we take the derivative, we set it equal to 0. That's what's happening here. Equal to 3, sorry. That's what's happening here. This guy, we took the derivative and we set it equal to 3. We took the derivative, set it equal to 3. And we set it equal to 3 because it has a slope of 3. Now solve that for x. Here, factoring does the trick for us, and we get 2 x values. Factoring, again, also works for us. For this guy, you could factor. Take this -3 over here, you get x squared minus 4, difference of 2 squares, or you can do it this way and take the square root of both sides. When you take the square root, don't forget to use plus or minus 2. Once you have your x values, you need the y's because we are looking for points, not x values. And so we go ahead and find those y values and then answer the question. The tangent line with slope of 3 occurs here. Do that again for this to find the y's, sentence answer, find the y's, sentence answer. So the factoring is going to vary depending on the problem that you use. You can use the square root method if you want. You can use quadratic formula, but why bother? Factor it if you can. We do use quadratic formula when we want to show that the thing is not factorable or has imaginary numbers. So it could be that you do one of these and you can't factor it, you can't use the square root method, and when you use the quadratic formula, you get an imaginary number. That means that there is no tangent line with that slope then. So that could also be a solution.